Okay, coming to the next lecture. So this lecture is regarding the histogram plotting using the Matplotlib package. So what is histogram? It is basically a very popular and very uh, core idea of the stats. So histograms are one of the most fundamental tool in data visualization. They provide graphical representation of data distribution showing how frequently each value or range of value occurs. So histograms are especially used for analyzing continuous numerical data such as measurements, sensors, readings, or experimental results, so on and so forth. So a histogram is type of a bar plot. So this is, we already know what is bar plotting, but this is basically a special type of bar plot where the x-axis represents intervals called bins of the data. So we will be calling these particular intervals as these bins to be more specific. And the y-axis represents the frequency values within each bin. So now using a histogram, so first of all, we will be importing the matplotlib library as plt, and then what next we are doing is that we are also importing the numpy library. So first of all, we are creating a numpy array in which we are generating 1,000 numbers, and since we have not mentioned the range, so what will happen is that the 1,000 numbers will be from the range of -3 up to -3 up to +3. So let's assume we have 1,000 numbers. That number could be -3, -2, 1, 0, 1, 2, or 3, but not any value other than just we mentioned here. So now we are resizing the figure to 6 and 3, and then we are using the histogram method here, which belongs to the PLT. And now the very first one contains the data itself. So we have generated data here. The data contains the 1,000 numbers ranging from -3 up to 3, and the color of that bars will be sky blue, and its colors will be equal to black, and the total number of beans is equal to 6. Now we are also doing one more thing, is that we are calling uh, the x-axis notations or limitations up to -3 up to +3. Now x label as values, y label as frequency, title is the basic histogram, and now we are showing the basic histogram here. So here you can see that uh, on the left side we have the frequencies of the numbers, and then we have the pins here. So basically this shows that the zero values have the very high number of frequency uh, from the total number of 1,000 numbers. Zero has the highest occurrence, -1 sorry, +1 has the second highest occurrence, -1 has the third highest occurrence, and then 2 to 3, or you can say that 3 has the uh, fourth highest occurrence, and -3 has the fifth highest occurrence. Okay, now we are going to the another example here. So in the example, instead of randomly generating 1,000 numbers from the range of -3 to 3, what we are doing that we will be generating the numbers from 1 to 10. So there will be total of 1,000 numbers here, and the minimum number could be 1 and the maximum number could be 10. uh, so what this function is doing here, or this particular statement doing is here, is that it's generating 1,000 number, and each of the number generated in these 1,000 numbers will be in the range of 1 to 10, including 1 and 10 itself. So resizing the figure here, and again we are calling the histogram method. First we are providing the numpy array here, and then total number of beans will be 5. The color of the bars will be sky blue, and the edge color is black as well. Now we are restricting the x-axis range from 1 to 10, And then we are also configuring the xticks. So xticks are basically these things here which we can see at the bottom, but these are not actually label of the x-axis labels. So x-axis label is here, and these are the tick labels, you can say. So we are arranging the tick label starting from 1, and it will go up to 10, and with the increment of 1. So this is the histogram. So again, in case if we want to do some extra experimentation here, is that if we, you can see that there are total number of 5 pins, 1 2 3 4 5. So if you want to shrink it down and use 3 pins instead of 5, then we will see only 3 pins. So within these 3 pins we can get the idea that the occurrence of numbers from 7 to 10 has the very high occurrences of numbers between 7 to 10, and then 4 to 7 has the second number of occurrences highest number, and 1 to 4 has the third lowest occurrence, but it is not very low. It is on average, that is the 300. Okay, so this is the complete information regarding the haste method. So x will take the input from you. The bins contains the number of bins, and the lower upper range of values which you want to show here is 0 to 5. So same as the density, weights, cumulative, color, edge color, his type, bar stack, step field, align if you want to align the bars. Uh, Currently these bars are aligned in image. You can change this alignment as well. On the ticks, on the horizontal ticks, similarly you can change the orientation. If you want to change the bar from uh, right to left, then you can use this horizontal here, otherwise vertical will be by default. Label, as you know, it is used for the legend, and transparency of bars, that is 0 to that could be 0 to 1 value, which is by default 0 per 7, I suppose. So okay, uh, customize histogram in the density plot. So one more thing you have to do here is that you have to also import the seaborn package here with the name, shortcut name as SNS. uh, Again, you are generating 1000 numbers whose range will be from -3 up to +3. So this is basically a normal distribution, and it always create a bell curve. And then customize histogram with the density plot. So again, data is the same, total number of bin will be 30. So KDE is equal to true. So what it actually does is that it creates that line here. So you can see the green line here. So this is basically visible just because of we set the KDE is equal to true, and the color of the bars is light green, and edge color is red. The rest of things are exactly the same. So if we execute it, we will get the corresponding data here. So first it will create or generate 1000 random numbers ranging from -3 up to 3, and now you can also see a KDE line as well. So now just in case if you want to create multiple histograms with these with subplots, so again we are using the PLT and NumPy as the shortcut names for the Matplot and NumPy packages, and then you are creating the data. One is the 1000 numbers whose range will be -3 up to 3, and then you are creating another data with the name data2, and we want to create subplots with multiple histograms. So fig axis is equal to plt dot subplots, and rows is equal to 1 and columns is equal to 2. So number of rows will be 1 and number of columns will be 2. So it means that there will be two figures or two subplots within the main figure, and basically it will contain two subplots aligned in a single row. So that is how you can control them. So axis 0 is equal to hist. So now we are the horizontal line will be named as axis. So on the 0 axis, or you can see on the 0 index, we are creating histogram here with our relevant data. You can see that we have provided data 1 as the input for the values. Total of pin will be 30, color is equal to yellow, as color is equal to black, and we are setting the title is equal to histogram 1. Similarly for the axis 1 is equal to his data 2 means rest of the thing is the same except the color is changed here, and the subtitle is also changed here. Now we are using the for loop here for ax and axis, so it will create these two subplots here. And title layout, we are also calling this function here with the help of the plt, and then we are showing that this is how you can get the uh, figure here. Now there is one more variant here, is that what we are doing is that we are generating random 2D data for the hex bin plot. So first we have created the data one as the x, and again it contains a random distribution uh, from the bell curve. It will create 1,000 numbers ranging from -t to +3, and what we are doing is that we are creating another 1,000 numbers, except we have multiplied first with the x and then added it with the generated number. So in this way we are creating another numpy array with the name y. And if you want to create a 2D histogram with the hex bin plot, so this is the another method. This is also histogram with a variant, and this is basically a 2D representation here. So we are provided the two numeric data, that is the x-axis generated values and the y-axis generated values. The grid size is equal to 30 and cmap is equal to blues. So x labels, again you are setting the labels and the title here for the xy and the main title, and color bar label is equal to count. So the color bar you are looking on the right side is actually created by using this particular method here. And now when we will execute this particular code here you can see a 2D histogram here. So this is it. If there are any questions you can ask. So since we provided two particular um, numpy arrays here, so the first numpy array is here on the x-axis, and the second numpy array which we generated here, so it basically represents the frequencies. And so this is it for today's lecture. Thank you very much for watching.